Now the question is, how do we understand there's a minimum number and why does binary search fit in over here? The game changes when you rotate the array. When you rotate the array, the number which you have at the beginning and the number that you have at the end, low's number is always less than the highest number because it is sorted in ascending order. Common sense. If it is sorted in ascending order, your first number is always going to be lesser than the last number. And I'll recalculate the mid. So mid is not here. This is the new mid. Now what happens? Is the number of mid greater than high? Is 5 greater than 1? Yes, it is. So low will be incremented. Hi everyone, welcome to my channel Code with Ease by Varsha. Today we are going to solve this Leetcode question, find minimum in a rotated sorted array. These are the companies in which it has already been asked. So we have done a bunch of questions already on binary search. So it's the binary search series where we have covered everything on binary search, and we have done some of the most popular tricky questions on binary search. Today we are going to do another question on binary search. So let's take a look at the problem statement. So we are given an array of length n. It is sorted in ascending order, but it is rotated 1 to n times. So whatever the length of the array is, max that many times it can be rotated. So if this is the array that we have, and if it is rotated 4 times, this is how the array is going to look like. It is talking about the right rotation in this case. And if it is rotated 7 times, we get it back to the original array. So any array, if it is rotated that many number of times, whatever is the length of the array, we'll get the original array. What we need to do is, you have to notice that whenever we are rotating an array, this is how the result is. So we have to return the minimum element of this array, given this array is only going to contain the unique elements. There is no number which is getting duplicated. And we have to write an algorithm that runs in log n time. So that is the reason why we are using binary search. So let's take a look at the example. So this is the array which is given to us. We can clearly see it has been rotated 3 times. The original array was this, and the minimum number is 1. Now the question is, how do we understand there's a minimum number and why does binary search fit in over here? Let's try to understand what is the edge cases, and then we'll see how can we apply binary search to solve this question. So let's talk about the edge cases first. What can be the edge case? Suppose you have only one element. If there's only one element like this, what is going to be the minimum element in that? So if it is one element, it is sorted also, and it is rotated also. It is rotated 1 to n times. What is my n? N is 1. So 1 rotating again is going to be 1 itself. So in that case, I just have to return the number itself. So this is the edge case. What can be the other cases? So suppose I take an example over here, 1, 2, 3, 4, 5, the original array, and let's rotate it 1 time. So I'll get 5, 1, 2, 3, 4. I'll rotate it again, and I'll get 4, 5, 1, 2, 3. So I did 2 rotations, and I got this as the final array. So when I get this as the final array, now what I want to figure out is what is the minimum element from here. So second edge case which I was talking of is there can be 2 types of rotation. One can be you can have n rotations itself. So this array, if it is rotated 5 times, you get the original array itself. When you do n rotations, you get the original array itself. And if you do anywhere between 1 to n rotations, you will not get the original array, but you will get the rotated array. So the point which we are trying to establish with this is we want you guys to observe a pattern. So what is a pattern that we want you guys to observe? See, if there are n rotations, we are getting the original array. If I'm getting the original array itself, I can say it is sorted and rotated. In that case, what is going to be the minimum element? In that case, the minimum element is going to be the first element itself. Or if I denote this by low pointer and high pointer, I can say nums of low. Simple. Always, when you rotate the array n number of times and you get the original array back, the first element is always going to be the minimum element. So with n rotations, I get nums of low. Great. But if it is somewhere between 1 to n, that we have to figure out. How can we actually obtain the minimum? So that is the approach which we want to discuss. So the observation in case of 1 to n rotations is, as over here, if I consider this as low and this as high, in case of the original array, the number which is at the low and the number which is at the high, low's number is always less than the highest number because it is sorted in ascending order. Common sense. If it is sorted in ascending order, your first number is always going to be lesser than the last number. The game changes when you rotate the array. When you rotate the array, the number which you have at the beginning and the number that you have at the end. Now, this again, I'm talking in case of 1 to n rotations. If it is exactly n, you get the original array. So the number at the low and the number of the high, see, the number at the low is greater than high. This is going to happen. So with this, let's try to do a dry run of how can we obtain the minimum element in that kind of a scenario. So I have 4, 5, 1, 2, 3. If I consider this as the low pointer and the high pointer, this is the mid. So we know how do we obtain the mid. I don't want to go through the formula of that because that is usual binary search algorithm. So we know that if there's a while loop where low is less than high and we know the computation. The first condition that we need to check is if it is n rotations or not. So for that, what we need to check is nums of the low, or I'll just write it in a different ink. First, we need to check is if nums of low is less than nums of high. My original array condition, which will denote exact n number of rotations. If that is the case, in that case, what you need to do, break out of this while loop. Because you don't have to find anything. You why do you want to do the rest of the approach if you can see that this number is less than high? So just break it. What we will return will come to that. Second scenario is if this condition is of course not true, then this is a case of a rotated array. So what we will do is we found the mid, right? So like I said, this number at low and this number of high, this will always be greater. So what we need to do is here we have to check if the number at the mid is greater than the number that we have at the last possible. If any part, I mean the numbers that you have before the minimum element, that is the first half of the array, in case of a rotated array, the first half of the array's numbers that you will have, if those number, if your mid falls in any of those numbers, those will always be greater than the last number. Sorry. This part of the array is greater than this. So that is what we're trying to say. Your mid is falling in this, then what you should do? Your low should be incremented. Because now we want to look rightwards. So my low should be equal to mid plus 1. And what is the else condition going to be? Just the opposite. High equal to, but not mid plus 1. Now suppose your mid is lying in this part of the array. This part of the array, probability is the minimum element will always be in second half of the array. So in that case, your high will be equal to mid itself. We're not going to do mid minus 1 because wherever your mid is, that can be a potential element, like in this case. Correct? So now if you do a dry run, mid greater than nums of high, 1 is greater than 3. No, it is not. So high will be equal to mid. So my high pointer is going to come over here. And I'll recalculate the mid. So mid is not here. This is the new mid. Now what happens? Is the number of mid greater than high? Is 5 greater than 1? Yes, it is. So low will be incremented. So low will be incremented to mid plus 1. So wherever your mid is, now low will come over here. This is the condition where your while loop will break because low less than h is no longer true. Now it is going to break. So what do we return at that? That's the question. We should return the number that you have at low, nums of low. In this case, nums of low is this number. So every time it will come to a situation where this while loop is going to break and you will come to that point or that number, which is your minimum element, and that's so we are returning nums of low. Now, if we come to this where we were trying to break, even in this case, when your low is less than high, that is the original array case, here also we will return nums of low. That is why we kept this as the common part. In either case, whether it is rotated n number of times or it is rotated 1 to n number of times, you are always going to return nums of low. This is the answer. Like, this is the return value basically. Similarly, if we take another example, suppose this array itself was rotated one more time. So instead of 4, 5, this, I can say that I was having 3, 4, 5, 1, and 2. Let's see this. This is the minimum element. So my low pointer is here. This is my high pointer. This is my mid. What was the condition? Mid's number greater than highs. Is 5 greater than 2? Yes, it is. So in that case, low should be incremented. Why? Because if this is your mid and this is your high, the probability is you have to go rightwards. So low should be mid plus 1. So this is where my low should be. What is going to be my new mid? This number. Again, mid greater than high is this 1 greater than 2? No, it is not. So high will come to mid. So high comes over here. This is where it is going to break. This now low and high are at the same number. And what did we say? When it breaks, we are returning nums of low. We're returning nums of low. So you can do as many number of dry runs as you want on rotated array, or you can do it anyway on this array. We are not going through this logic itself because we're breaking out of the loop in this case. So this is how we can use binary search to figure out the minimum element in a sorted rotated array. Thank you so much for watching the video. So the code for this is already available. It's written in Java. You can check out in the description for the GitHub repo.